without any further delay, I'd like to welcome the panel on stage. Can we have the slide up, please? Thank you. And we will be talking about Industry 4.0 to 5.0 and new trends in the context of manufacturing. So I would like to invite all the panelists to come up on stage, please. And if you could take a seat underneath your photograph, so starting with Engineer Sami Sarhan next to me. Thank you very much, gentlemen. And we have Karim Purak from Process Miner, and we are missing Mehmet from Alloy Additive. Oh, here he is. He's our 3D printing guy. And then we have Abdallah Sana from Tulip. Thank you very much for joining us. I'm going to move to my seat. Gentlemen, when we start, it's best to be as close to the microphone as possible so everybody out there can hear you. I think this is an incredibly interesting panel because I don't know what 5.0 means. I'm used to hearing 4.0 all the time, but 5.0 is this reimagined kind of world that we're in. And so it's going to be interesting to see the interplay between 4.0 processes that our three panelists from industry are going to be talking about, and then from 5.0 from Sami Sarhan from the Ministry of Industry. But let's start, and I'm going to ask each of you to give us 1 minute on who you are, where you're from, and your favorite restaurant. Now, I'm just joking about the restaurant, okay?
All right, so I'll start. Can you hear me? Okay, good. So, Sami Sarhan, I'm the Chief Advisor at the National Industrial Development Center, specifically at the machinery equipment. I look after the Industry 4.0 and new technologies investment opportunities. As Dr. Al-Hajdi was explaining, the National Industrial Development Center is the FDI arm of the ministry. So we basically localize manufacturing into the kingdoms. Very high level, I focus on technologies related to robotics, IoTs, anything related to 3D printing localizations, printed circuit boards, semiconductor, all of that is in the heart of Industry 4.0. Thank you.
Thank you.
All right. Good afternoon, everyone. My name is Karim Purak. I'm the founder and CEO of Process Miner. We are a US-based company with offices in Europe and in Middle East as well. Process Miner is an AI for manufacturing optimization company. Our platform is now deployed globally to over 30 different manufacturing facilities. And in a nutshell, what we do is we optimize the manufacturing processes, more specifically continuous and semi-continuous manufacturing processes in real time and autonomously to produce better quality products while the machine is running, as well as reduce the consumption of a raw material that results in reduction of the manufacturing cost. And of course, one of the big areas that is a subject of this conversation is the digital transformation services that we provide our customers that are ready to start their journey into digitizing their existing processes and also help them with upskilling their existing workforce. Glad to be here.
Thank you. Mehmet?
Assalamu alaikum. This is Mehmet Çetinkaya, founder of Alloy Additive. I'm metallurgical and materials engineer actually, and I hold mechanical engineering, and I did some space experiments. I'm telling this because the idea, and Alloy Additive idea, comes from my bachelor years actually. 3D printing is really new trend, but also we see really good examples and applications in the industry as well. My idea on Alloy Additive was also during my work in the rocket company. So I have 6 years of experience in a rocket company, and we achieved to reach up to 100 kilometers during my career in the company. And Alloy Additive is actually a 5 years old company. For a startup, it's really good timing, but for a general company, it's still really young and dynamic. Our engineers are also really dynamic, and that is all about me.
Thank you.
Assalamu alaikum. My name is Abdullah Sanna'. I am the CEO and the partner at Tulip Technologies. We've been working in the industrial automation field for the past 35 years. We are actually mainly helping factories transform into smart manufacturing with the core of robotics. So we help them mainly automate their manual processes in all sorts of industries and factories, in the metal, in the FMCG, in textile, paper industry. So we try to help them move into, let's say, the Industry 4.0 and Industry 5.0 as well.
Thank you. Mr. Suna, could you just tell us from the Tulip product range, what are you offering the Saudi market in particular, and what seems to be the most popular applications out there, so these guys are clear about really
Sure.
what you do?
Sure. So actually what we offer is aligns with the current industries that are available and famous in Saudi Arabia. So when we come to, let's say, metal industries, everything related to metal fabrication, automotive, we are doing lots of automation related to welding, steel welding, aluminum welding, drilling, riveting. So we automate all these processes with robotics, coating as well, metal inspection, so many other applications like also sanding and surface finishing, CNC feeding, all of that we automate with robotics in the metal industry. When we go into FMCG, fast-moving consumer goods, food and beverage, pharma, everything you see in the supermarket, in all these factories we automate the end-of-line processes, which are packing, packaging, palletizing, even intralogistics, which is moving the pallets after it's finished from the production line, moving it to the warehouse. We automate all of this process. And also, of course, in the beginning of the line, feeding the components or the packages into the line to be filled, and then we handle them at the end of the line. Also, we have worked actually with the military industry for some special applications. We work with the textile industry, with the paper industry for similar applications. Also, currently we are working on some lab automation with robotics as well. And we have deployed actually some robots in labs in some hospitals as well. It's actually, when you look at robots, you have more than 150 different applications worldwide that you can use these robots with. But it depends on your client needs. So we actually try to understand their manual process, and then we design a system that can automate that process efficiently.
Oh, thank you very much. Mehmet, can you just tell us a little bit about alloy additive print, just so that everybody understands? Because I've never seen 3D printing of metals before. It's pretty amazing.
Starting from the problem is the key, actually. So there are two problems in 3D printing. One of them is a serial manufacturing problem, and the other one is the deposition rate. The process is really slow compared to conventional methods, for example, casting. You cast a part, you obtain the final part within 30 seconds. In 3D printing, it takes maybe days. So we solve this problem and we try to increase our deposition rates up to 8 kilograms per hour. Which is really quick process, which is really decreasing the cost of the process, and so that it is really applicable for all industries, because cost-effective solutions are really key. In 3D printing, generally what we see is parts are really expensive, but with our method, which is called wire arc additive manufacturing, we provide high deposition rate so that whole process is quicker, cost-effective, and it really solves the industrial problems. The main advantage in wire additive manufacturing is it is capable of printing large scales, meaning up to meters. We have two systems now back in Turkey. One of them is capable of printing 1 by 1 by 1.5 meters cube, and the other one is up to 3 meters. So I'm talking about really large parts. In conventional ways, let's say forging, it might take 2 years to obtain one on a simple ring with the conventional way. But in our system, since we have high deposition rate capability, it might take just days. And after finishing CNC machining and final procedures, the customer can obtain the part within 2 months. So instead of years, it might be really months, even in some particular cases, it might be weeks. So these are the main advantages and the core of the technology.
And where are the main sort of market sectors for alloy printing? Just to give us an idea.
It really depends on the material. If you go for titanium alloy, for example, which is really critical for us, we have different technology compared to other wire arc additive manufacturing companies. This provides capability to print titanium, and titanium is really special for aerospace applications, rocket applications, for example. If you go for Inconel, for example, it is really special material for energy and also oil and gas. We have capabilities on stainless steel as well, and for energy, maritime, and other industries. Again, this is a really useful material. So it really depends on the material and also the industry and also the geometry. If the geometry is feasible, then the method becomes really, really valuable and the only one the one can select.
Can I turn to Mr. Karim now, and intelligent manufacturing optimization. So automation is going to do that, and you already mentioned some efficiency in terms of the use of raw materials, etc. Could you just expand on all that and give us, maybe a couple of examples of your success?
Certainly. I think the transition from Industry 3.0, which was a traditional automation, to 4.0, that it's all about data connectivity and automation. And now we're even very early on talking about 5.0, right? Which the biggest difference between 4.0 and 5.0 is that human-centric nature of revolutionizing this industry. On the 4.0 part, that data connectivity that leads to a better automation is what we are focusing on. We see that a lot of manufacturers around the globe collecting a lot of data, and they're drowned in data, but we always say that they're starved for information. The fact that they collected a lot of data throughout their process and never really truly optimized their system and made decision on that data, it's an opportunity. What we do is we collect these certain set of historical data from the customer and do a very detailed analysis on how we can optimize the system in real time. I think the key difference is from a traditional automation to the AI-based continuous optimization and autonomous optimization on top of that, is that maintaining this optimization while the system is running, right? Because the key values that a system like this would deliver to the company can impact the consumption of energy, raw material, making better quality product. And above all that, there's a big problem throughout the manufacturing industry globally of shortage for skilled labor, right? The engineers that are retiring, the new engineers that are coming, and they don't have enough experience. So a lot of folks that worked in these manufacturing environments, they had a lot of experience that is very important to build any intelligent system today. So I think that's where the conversation of 5.0 is. What we did from a day one, we actually, as a pillar to our platform, we brought in a domain expertise knowledge and combined it with the advanced machine learning and data science knowledge to be able to deliver a applied science platform that can truly deliver value to the customers right now.
So in Saudi, we have the Smart Factories program. And this is about automating factories, 4.0 technologies being used. What do you feel the challenges are here in Saudi Arabia for more adoption of automation and those associated technologies?
Very good question. So this is the third year actually I'm traveling every year to Saudi Arabia. And there's certainly a major potential here based on all the initiatives that governments are putting out, the support that government gives to the manufacturing industry. And of course, there's always the adoption challenges. But before the adoption challenges, you have to look at the sort of the awareness and mindset and education for manufacturing industry here. I think the will is here, the fund for that is here, but the sort of the awareness of what this digital transformation needs to start from is actually lacking, right? There's a lack of infrastructure, but the good news is, I was talking to Mr. Abdullah earlier today, that this third year that I'm here, now I see companies that when they come and talk to us, we ask them that, do you collect data? Are you modernized on your machine? And they actually say yes. There are a few companies that they have machines with a lot of sensors on them. They are collecting data. So they're really taking that step. So we are seeing that the awareness that is actually supported by government and other institutions really start beginning to settle in, and manufacturers, they see that. But in terms of a challenge, again, it's the infrastructure, the mindset and leadership in these companies, and understanding that this is a journey. This is not something that you can do in a matter of a year or two. They have to invest into it from a infrastructure, from the human resources, as well as education.
So in the US, for example, how long has that journey been so far, this automation journey?
Well, it depends on what part of the world you are in, right? So and what industry, as a matter of fact. There are certain industries that are pretty advanced already, and they're adopting this type of technology a lot faster. There are certain industries that are behind. But also in the regions, right? Because if you had a traditional way of manufacturing, and that traditional way is nothing wrong with it, it has worked and it's great, but to be competitive today, right, countries have to start adopting, and there's no other option. I think the gentleman before us, when he spoke, he said that innovation is not an option anymore, it's a must, right? It is happening no matter what. There are challenges that we have to overcome by adopting the advanced technologies like AI, generative AI, or any other automation components. But keep in mind, you don't need to jump from where we are to AI already. You can take baby steps, right? Even go to business intelligence first, build infrastructure, educate, make awareness, and then take the company to the next level.
Okay. Engineer Sarhan, so you're kind of in the middle of this transformation thing in your job, and we're talking about 4.0 particularly, but it might be an idea to kind of brief everybody in the audience. What do we mean by 5.0 and that transition? What's the deal on that?
Exactly. So this is a good segue from Kareem as well. So building on what he said, just a little bit going back into the history to understand the transition. So Industry 1.0 was basically based on steam, and then 2.0 was basically on electricity. So we're focused on basically energy and power. 3.0, then the .com era came in, and ITC and automation. So now we're focusing a little bit on adopting processes that will actually help manufacturers to move on. In 2011, Hannover Messe, there was official announcement of Industry 4.0, where basically now we are in the heart of using technologies related to robotics, technology related to AI, big data, and all of that. There was a hype among a lot of experts that jobs will be taken away. Now, these robotics will come and displace people, and then a lot of the technological advancement will come and take away people's job. So then, in the European Union the European Commission published a paper about Industry 5.0, and that was exactly the birth of it in about January 2021. Idea is that, as Kareem was saying, basically three main things: human-centric, so looking at people and put it in the middle of your factory and looking at them specifically how they can actually have a stronger role. Innovation, anything related to sustainability, anything related to resilience. That's where Industry 5.0 actually was came in. Now, honestly speaking, again, if you ask me the questions, I think it's all related to skill development. I don't know if it's the right way to call it Industry 5.0, but I would focus on the actual requirement of today's factories and manufacturing. There's a huge gap in skill development, and I think that you all heard about the term saying that AI will not take your job, but people who learned AI will take your job. So what basically, the message is that you need to deepen your knowledge and understanding on how these new technology can be applied, can be worked. Today I look at Gen AI as a tool. Just like many years when the calculators came in, mathematicians went into a rally and they were actually against it. So long story short, the more we actually focus on skill development related to new technologies, then we will be honestly safe when it comes to we don't really have to say it's Industry 5.0, but we can say that the more skills development we have, the more we can cop up people and be able to make them available into the Industry 4.0 factories.
So we're really talking about talent development here.
Exactly. If you go at the bottom of it, like for example, the Industry 5.0, if you read that report, is all saying that people had this fear that, I'm going to lose my job, or I'm going to move away because this robotic now will take away 5 laborers. However, if you learn how to operate that robot, then you have a job. Then maybe Abdullah can actually explain this in more detail. So what I'm saying is that what we need to do, we need to focus on skill development and focus on talent development and close that gap as much as possible.
Yep. And I'd like to piggyback what you said.
Everybody get the 5.0? Yeah? Okay. If you're not sure, this guy will be around afterwards. You can always tap him up and he'll explain to you with crayons. Okay?
I want to actually add
please,
what Sami said. I think it was great to emphasize on this, because upskilling the existing workforce is becoming sort of a central purpose of a lot of work that we are doing. To give you an example, last night, the United States announced that by 2033, there's going to be more than 3 million operators' job vacant. Meaning that we don't have even enough people today to run things. And then when the time goes by, if you don't have these skilled operators, right, that learn how to adapt with AI and other technologies, they have to fill this gap with that knowledge, right? So it's very, very important. I'm glad Sami touched on that.
I'm going to turn to Mehmet and Abdullah as well. I mean, what's your feeling, Mehmet, on this talent gap in Turkey, for example?
Actually, adapting the new technology is really challenging. And we see this in our company. It's really young, dynamic company, and adding these sensors, collecting data, using the AI in the right way is really critical. What we do is also the application in 3D printing as well. 3D printing is a tool, AI is a tool. We need to use those in the right way to get the benefit of it. So the same thing in Turkey. It's, the generation is really young, dynamic, and they really try to learn as much as possible. So we are also trying to adapting these new technologies as a company, as a young generation. So I think this is really critical to understand. These tools are really effective if you use them in the right way.
And Mr. Abdullah, I mean, in terms of installation of robotics processes and things like that you're doing in Saudi Arabia, how are you dealing with this talent gap?
Yeah, so I think what the gentleman mentioned is very important, and I can tell you that the transition into Industry 5.0 has already started in Saudi Arabia. Actually, the robotics technology has advanced in the past 10 years, 10 to 15 years, where they, especially leading robotics manufacturers now, are trying to democratize this technology. Now they are making it accessible to everybody. You don't need to be an expert to program a robot anymore. You don't need to be, let's say, a programmer or a genius to do that. Everybody now can program a robot. Everybody can now mix his knowledge, his know-how with robots and build something unique. And I can tell you, for example, in one of the factories that we have deployed these, we call them collaborative robots. The collaborative robots are designed to work with humans, not to take your job. Actually, we say that they are designed to make humans work with robots, not like robots. Because in many cases, when you go to factories, you find people are working just like robots, picking one item from one place and putting it in another without any thinking, without actually making their brain work. What robotics are now doing, they are actually empowering these workers, empowering these people to do more and to produce more. And for example, I can give you one case that we have deployed in one factory in the second industrial area in Riyadh. Workers used to do lots of welding work in a metal fabrication factory by themselves, and usually quality is different from one welder to another, and it depends on how tired he is. Now we have deployed like around maybe 8 robots there just to automate this. And these welders who used to weld by their hands, now they are welding with robots. First of all, their like capacity increased dramatically. And at second, of course, they are getting very high quality consistently. So it's very important that we are empowering these people. They are not engineers, they are technicians who are experts in welding, but they are not technology experts. What we did is we enabled them with robots. We taught them how to use these robots, how to program them. All these robots are actually programmed with the low-code, no-code technology. You don't need to write a code in order to program it. You just move the robot with your hand, take it to the point, and save that point, and so on, and then you have your program. So it's actually now empowering all these factories with the same factory area, with the same number of workers. They are producing more and more without the need to add more resources into their factory. And this, let's say, answering also your question regarding the knowledge gap, there is now a huge interest from people and from students into this. We have already deployed some robots in KAUST University. We have deployed some robots now in KFU PM University, Prince Sultan University, different universities. All these, let's say, students now are learning how to use the actual industrial robot and collaborative robot, and they will be working at the end of the day and empowering their organizations afterwards.
Thank you. I read the other day when I was doing some research about digital twins. Who knows what a digital twin is? Hands up. Oh, 2 of you. Okay. Sammy's turn now. Yeah. Sammy, generative AI and digital twins. Tell us all about it.
Right. So let's focus on AI, for example, from an industry perspective. I'd like to give an example since I'm a drone pilot. So drone is a type of robotics, right? An AI-powered drone are very powerful. So for example, if you want to scan, let's say, a communication tower, it will do 30 and 40% of the job before you send the technician up, okay? It will probably understand if there's a corrosion, if there's a crack, if there's anything that is actually, and then the rest of the job can be done by human. Okay, so this is right there. The same Shell, for example, actually implemented this in flares, and they were actually sending these AI-powered drones up to the flares to take a very high definition pictures and analyze some of the corrosions, analyze some of the hot points, analyze some of the cracks if there is any, and then the engineers can actually go and do the job. Similar to digital twin. The digital twin is a replica of a real systems or even a factory or even a whole site. The idea of digital twin is running what-if scenarios. So if you want to run that what-if scenario in a real system, you might have to shut down, you might have to lose your production line, you may have to lose time on people, but in doing it in digital twin, you will be able to do what-if scenario, and you will be able to do a good decision before you actually apply it into the real time. Now, where does Industry 5.0 comes? Where is the human-centric? Again, these changes that will happen on the industrial side itself will have to be done by human. So a lot of these technologies, the more you know it, the more you understand how it can apply, the more you know that human factor of it is very important and crucial and probably in the middle of it. So I hope I answered this question
it's like a predictive analysis tool, is it?
Exactly. You run a lot of what-if scenarios. You want to change something. Before you go and do it in the actual system, you actually do it in a digital tool system.
Okay, great. So I'm going to move on to the 4,000 factory story that I mentioned before for you, Kareem. So the transformations of old factories into new. Tell me a bit about the process, how long that takes, and what are you seeing in Saudi Arabia in terms of that?
I think, as I mentioned earlier, the government support here seems to be paying off. This is, and I'm seeing this year by year coming here. I think the awareness is getting much better. I think the readiness is happening. We see more companies with more modernized. I was talking to Mr. Abdullah earlier about this also, that we are meeting actually manufacturers that they do have new machines with instrumentation. They have old machines that they have modernized, and they are actually beginning their transformation. So obviously this starts with having the infrastructure in place, right? Modernization of their instruments, collecting their data, and also have a vision, what is it that they want to do with this transformation. If it's about the quality of a product, if it's about reducing the production, if the main focus is the sustainability, or I would say this upskilling their existing workforce, right? Educating them, making them better engineers, better operators. There is obviously the trend, and depends on what industry has more capabilities, they're faster taking to this journey. But above all what I mentioned here, the leadership and executing the vision is very, very important, right? If you have to stay very focused on what you're trying to do and understand that this is a transformation, this is a marathon, not a sprint, right? So you have to have clear goals of every segment and every phase of this transformation. And I definitely see a major progress, and I am very optimistic. I think the Saudi Arabian manufacturing industry is definitely in the right direction to get modernized, and hopefully, inshallah, very soon get to be very competitive out there in the world.
Thank you. Okay, we're very close to the end of the session, so I'm going to ask Mehmet and Abdullah for 1 minute each. So, what are you hoping your technology can achieve for Saudi Arabia between the two of you? Mehmet, if you go first.
We have a concept of digitalized warehouse. So this is really critical. As digital driven, this digitalized warehouse is also critical, because consider a warehouse, thousands of parts are staying there. Maybe you will be using them or no, according to your overhaul repair requirements. So we have this concept in Additive, so that we can manufacture a part when it is needed. So you don't need to store the real part, you don't need to manufacture it. When you need it, you can manufacture and go on with it. There are really huge companies in Saudi Arabia, and they are really old companies. I mean, they have really good history. So they have old parts needed to be repaired or needed to be replaced. So this digitalized warehouse concept can provide really good material upgrade, material usage when it is needed. So our vision on providing those products to those really large companies.
Thank you. And last but not least, Abdullah.
Thank you.
You got 1 minute.
Sure. I think, let's put it this way, there are lots of unique and special companies in Saudi Arabia, and they are very successful in the local market and in the region. And with robotics and with Industry 4.0 and 5.0, they will be able to scale their operations worldwide and deliver this success actually to all over the world, not only in Saudi Arabia and in the region. And technology and robotics is a very strong enabler to do that.
Thank you very much. That was fantastic. I learned a lot. I hope you did. Please give the panelists a big round of applause on 4.0 to 5.0. And if I could ask all of you to the middle of the stage here, we're going to do a group photo.
Okay,
Thank you. Can we have the photographer, please?